Hi, welcome back to the channel. We'll take a worked example to help us understand how to find the area between a curve and a straight line. That said, let's get into class. Our worked example says that we should find the area between a curve. The curve is given as y is equals to x squared minus 4x plus 20, and the line y is given as 3x. And both of them intersect at x is equals to 0 and x is equals to 4. Now, the first thing we want to do is to draw these lines and see their point of intersection and see how the difference between the curves and the straight line. The first thing you should note is the straight line is given as 3x. Now, the equation for our straight line from our fundamentals we know is given as mx plus c, where c is the intercept with the y-axis. Obviously, this line has no intercept, or rather, this line has an intercept with the y-axis at 0. So that at 0, which is the origin, that line intersected with the y-axis, because this is same thing as saying y is equals to 3x plus 0. So that means my straight line is going to pass through 0, and it has a gradient of 3 because my m in this case is equals to 3. Now, but we'll be told that this line passes through 0 and also they intersect at 4. Now, if you look at the nature of the the curve also will definitely pass through 0 because we've been told it passed through 0 and 4. So I want to draw my curve this way. I have my curve this way. So that the area we're now interested in looking for is the area between the curve and the straight line So like we did in our other lesson, we took the area of the curve to be equals to A. The area of the curve is A1, and the area between the straight line and my x-axis is also A2, so that the area between the curve and the straight line will be tagged as A, will be given as A2 or A1 minus A2. Now let's open a new slide. Now, so that my A1, the total area, like we said initially, will be given as A1 minus A2, where my A1 is the area of the curve, will come from the integration of between 4 and 0 of the curve. The curve is given as x squared minus 4x plus 20. Now, so the integration of this with respect to the x, a1 will come from integrating x squared becomes x raised to the power 2 plus 1 over 2 plus 1 using the formula for integration. 4x, integrating it becomes 1 plus 1 over 1 plus 1, and plus 20 becomes 20x, all moving between 4 and 0. So that this is the same thing as x raised to the power 3 over 3 minus 4x raised to the power 2 over 2 plus 20x, all moving between 4 and 0. So that my A1, which is the area of the curve, will now come from, obviously, this will be 4 raised to the power 3 over 3 minus 4 into 4 raised to the power 2 over 2 plus 20 into 4. Now, everything here minus. We're now going to repeat the whole of this equation with 0 over 3. Obviously, everything here becomes 0. So I can do away with that. So I can do away with this part of the equation, so that my A1, which is the area, will be the same thing as 4 over 3. That's 64 over 3. Yes, let me use my calculator. 64 divided by 3 will be the same thing as 21.33. That's 21.3. And here I have 2. 2 here is 1. 2 in 4 is 2. 2 times this 4 is part 2 is 16. 2 times 16 is 32 plus 20 times 4. That's 80. So this gives us our A1. So that's 21.3 minus 32 plus 80, that's 69, that's 69.3. Let's look for A2. A2, obviously, A2, this is not A1. A2 will come from the integration of the straight line, that's 3x, with respect to the x is ranging between 4 also and 0, so that A2 will be the same thing as integrating 3x becomes 3x squared over 2 ranging between 4 and 0. So that A2 obviously will be the same thing as 3 into 4 raised to power 2 over 2, now minus 3x. When x is equal to 0, everything becomes 0. So I can leave that side off. This is the same thing as 3 times 16. 4 times 4 over 2, that's 4 times 4 is 16 over 2. 16, 2 here is 1. 2 and 16 is 8. That's the same thing as 24. So that my total area, final area, can now come from, which is A1 minus A2, will come from 69.3 minus 24. 69.3 minus 24. Obviously, that's the same thing as 45.3 units squared. 3. Remember, area is measured in units squared. 45.3 units squared. Will this help you further understand how to calculate or how to find the area between a curve and a straight line that meets at 2 points? Thank you for staying with us and see you in our next class.